Hello everyone, my name is Anderson. I'm a master's degree student from the Federal University of Itajuba here in Brazil. And with the help of my advisors, Professor Marcelo Robai and Professor José Alberto, we are exploring a project that involves technology and nature in the field of smart agriculture and sustainable farming. Together, we're developing a project to estimate the number of bees entering and exiting a beehive, which is a crucial task for beekeeping and ecological study. The title is The Use of TinyML for a Non-Invasive Beehive Monitoring System. Well, in our project, we use a Raspberry Pi 02W, which is a powerful edge computing board with 1 GHz quad-core CPU and 512 megabytes of RAM. We had to increase a little bit of this RAM size in order to our model work better. We'll talk more about this further in this presentation. And inside the Raspberry, we ran a module called YOLO V8 from Ultralytics, which is a real-time object detection module and offers a very good performance in terms of speed and accuracy. Let's talk about the importance of bees. Well, bees are very important to us. The most important factor is the pollination, because bees are the most common pollinator. And the work of the bees are crucial for the reproduction of the plants. And also bees help the humans to ensure the sustainability, and at least 1/3 of the food production depends on bees. Also, bees can provide us with some important food like honey, like beeswax and propolis and others. And in some rural communities, bees are a very important source of income. Okay, so to start our project, we had to create a data set. In fact, the data set collection is the most critical phase of the project and should take weeks, even months to be created. And we asked permission for a beekeeper to take pictures of his beehive. Here's some examples of the pictures. Well, after take the pictures of the beehive entrance, we used a online platform called RoboFlow to label each bee on the picture. This platform helped us a lot, and with the auto label function inside the platform, we save a lot of time because it performed a auto label for us. Of course, we have to work on some pictures, like some of them wasn't marked, and we had to manually mark the bee, but was a very good platform for us.
So, this is an interesting function on RoboFlow that helped me out during the labeling process. As you can see here, the bees aren't marked so far. So, what I did, I trained a small module with around 80 images, and after that I have a small module to help me during the labeling process of my thousands of images. So basically what I need to do is click here on Label Assist, wait to select my model, which is bees, the name, and select the model. It takes a few moments because it's loading the model. Okay. And now all the bees are marked. And I can adjust the confidence and the overlap on these functions. So this helped me out during the more than 1,000 images that I had to label during the process of the creation of my data set.
After labeling all the bees in the pictures, we split the pictures in groups for training, validation, and test, and we was able to export the dataset in the YOLO V8 format. We had two options. We was capable of export the zip file of the pictures with the bees marked, and also we have the link to download directly from our module. Well, after that we was able to train our dataset. We import all the dataset that we created on a RoboFlow, and we perform a training. Here's a picture of our model during the training phase. We use a Google Colab when we use a Jupyter notebook to create the model. Okay, so this is the training results of the model. The model took around 2.7 hours to be trained and showed an excellent performance. As you can see in this picture, the majority of bees was marked on the screen. So this shows us how good our system is. The next phase of the project is to install YOLO V8 inside the Raspberry and put the Raspberry with the camera connected in front of the beehive entrance in order to estimate the number of bees entering and exiting the beehive. First, to install a operational systems inside the Raspberry, we decided to use a light version, and we did a memory swap by separate part of the SD card memory to be used as a memory inside the Raspberry Pi. This is very important because YOLO V8 is a heavy module, and with the memory swap the performance increased. After that, we ran a YOLO V8 inside the Raspberry, and as you can see in this test image, the YOLO was able to detect all the different objects in the picture. After that, we upload some image of the beehive entrance that we took before inside the Raspberry and ran the model YOLO V8 inside the Raspberry in order to see the results. And also the model worked very good. And what we really want in the end of this project is take pictures of the beehive entrance, like from 10 to 10 seconds, and perform an inference and estimate the number of bees in the beehive entrance and send this information to a beehive owner. So the owner will be able to know if the beehive is okay or if something is wrong without going to the beehive. That's our goal for this project. We can upload this information on a website or on an app, and the beehive owner can access right in his hand.
I'd like to record a special thank you to the professors Marcelo Rovai and Professor José Alberto for all the support, all the advices during this project. Thank you very much.